This tutorial is for 4th grade, Module 6, Lesson 2. In this lesson, we're going to see how decimals relate to mixed numerals and how we can locate them on a ruler. The directions say write each decimal as a mixed number, put an arrow where the number is found on the ruler. My first number is read 2 6/10 centimeters. We say the word "and" in place of the decimal point. The first spot after the decimal point is the tenths spot. The first spot before the decimal point is our ones place or our units place, as usual when we're working with whole numbers. So again, we would read this as 2 6/10. The last word I'm saying is the word that tells me the spot that the 6 is in. So how do we write 2 6/10 as a mixed numeral? Well, that would be 2 whole numbers, 6/10 as a fraction. So 2 6/10 as a decimal is the same thing as 2 6/10 written in fraction form. Now we need to locate 2 6/10 on the ruler. Well, my first mark is 1 centimeter. So the next mark would be 2 centimeters, and the next long mark would be 3 centimeters. I know that 2 6/10 is in between 2 centimeters and 3 centimeters, and you can see that centimeter has been divided into tenths. So we just need to find the 6/10 mark. So if I count from the 2 centimeters mark, here's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So this mark on my ruler represents the 2 6/10 centimeters mark. It can also be written in decimal form, 2 6/10 centimeters on the ruler. Let's look at another example. This decimal would be read 3 4/10 centimeters. So as a mixed numeral, that would be 3 for my whole number and 4/10 for my fraction. To find that on my ruler, I know that it will be between 3 centimeters and 4 centimeters. So here's 2 centimeters, 3 centimeters, and 4 centimeters. So it's going to be between the 3 and the 4 centimeter mark. And again, the centimeter has been divided into tenths. So I just have to find the 4/10 mark. So here's 1/10, 2/10, 3/10, 4/10. So here's my 3 4/10 centimeter mark on the ruler. I can also write that in fraction form. They both refer to the same point on the ruler. The next question says to write the following as equivalent decimals, then model and rename the number as shown below. What that means is I have 2 ones and 6/10. I need to write that in decimal form first. So the 2 ones refers to how many whole numbers I have. The "and" is where my decimal point goes. And now I have to show 6 in the tenths spot, and that just means the first spot after the decimal. So this unit form here just tells me where the 6 is going to land in my decimal. Now I need to shade in my models to show 2 6/10. Well, like I said, the 2 represents 2 wholes, so I'm going to shade in both of the first squares. That will give me 2 wholes. The 6 refers to 6/10, or 6 out of 10. That means I'm going to shade in 6 sections on the last model to show the 6/10. And here I have a model that shows 2 6/10. These 2 squares are my 2 whole numbers, and this part of the third square represents 6/10. Here in the next question, I have 2 5/10. That would be written again as 2 whole numbers and 5 in the tenths spot of the decimals. And I will shade that in on the model below. So I'll shade in 2 full squares and 5 out of the 10 sections on the last square. So now I have a matching model. These 2 squares show me my 2 whole numbers, and this part shows me my 5/10. Now the last part of the question says how much more is needed to get to 3. And by 3 that means 3 whole squares. So you can see the part on the last square that is not shaded. There are 5 sections out of 10. So 5/10 still needs to be shaded, or in decimal form 0.5. Once that is shaded, that would get us to 3 wholes. My final question asks for 37/10. Now let's think about what that means. It takes 10 to make a whole, and I have 37, so I have enough to make 3 wholes. So I'm going to shade in these 3 squares. That would show my 3 wholes, or 30/10. Then I'll need to shade in 7 more to show my extra 7/10. So 37/10 is 3 wholes and 7 more tenths. As a decimal, I would write that as 3.7. I can still read this as 37/10, or I could read it as 3 7/10. Means the same thing. 37/10 would be 37 pieces, and each piece is a tenth. So I'll go ahead and shade in those squares to show that. And here are my 37/10, which again is the same thing as 3 wholes and 7/10. Now, how much is needed to get to 4 wholes? Again, we can look at the very last square, and you'll see that there are 3 sections that are not filled. If we could fill in those 3 sections, we would have 4 wholes altogether. So we still need 3/10, or in decimal form, 0.3.